Hi, this is Marc Roth. This is Mathematics for Social Justice. So this next video is going to be on Pigeonhole Puzzles Part 3. In the previous videos, I went the whole rationale of showing one way to do this. So rather than repeat all that, I'll just tell you that I start now with 9 or 18. And I always find the digit sum of this, which you can ignore 9s, because we're working mod 9, and 9 is equal to 0 on a mod 9 clock. So you can ignore that number and that number, just work with the 3. So you put the 3 there, then connect those two because they're both odd. If they had both been even, you would have connected those two. Now the next thing you do is just subtract and cut it in half. So when you subtract, you get 6. Half of that is 3, so this is 3. So let's motivate that by doing this. So I probably mentioned in the other video, I guess I will repeat this. We can think of all the numbers 1 through 9 as being above this bar to begin with, and we'll bring one down later. So, so the numbers 1 through 9 add up to 45, which on the mod 9 clock is equal to 9 or 18. Okay, so these numbers are all equal on the mod 9 clock. So these numbers 1 through 9, when you add them up, you get, these are all equivalent answers. So in particular, I'm picking on 9 and 18. So down here, you can ignore the two 9s like I said, and the 3 can go here. Now we're going to bring one of these numbers 1 through 9 down and put it here. Again, so you subtract and then you cut it in half. So you subtract, you get 6, half of that is 3. So basically, in general, if we have a number A and a number B, and just call this number in the middle M, what do you add to the bottom to take you to the middle? So basically, when you're done bringing this number down, when you do the addition problem, if this was money, this money would equal this money. So what would you bring down to make this money equal to this money? So I like to use this mall example. I probably said it before in a previous video. If you're really good friends with somebody and you're walking in the mall with $12 and your friend has only 8, you would give him 2, because that would bring you down from 12 to 10 and bring him up from 8 to 10. So the question is, what do you bring down to the bottom to take the bottom up to the middle? So in this case, if you went all the way from A to B, that distance would be B minus A. So this distance is B minus A divided by 2. So that's basically why you're subtracting and then dividing by 2. Okay, so now we're going to solve the problem, and once again, we're not going to write down anything unless we've eliminated every other possibility so that we end up getting a uniqueness proof. And once again, we're going to assume that this number is less than this is less than this is less than this, and this is less than this. So I actually think this won't be 1 and 2. I think it's going to be 7, 8, or 9 here. But to eliminate that possibility, let me try 1 or 2. Well, if this is 1 or 2, I would carry 0. And the question is, where could I put my 9? Well, I couldn't put the 9 here or here, so the 9 would have to go here. And then, so if this is 1 and 2, this would be 9 and 4. And then if I had 9 and 4, I'd have to carry 1. So these two numbers would have to add up to 8. I wouldn't be able to put my 8 here, so the 8 would have to go here. And this would have to be 1. But again, I've already said that I've used my 1 or 2 here. So I couldn't put the 8 here with a 1 because the 1's already been used. So I could put the 9 here, but then I wouldn't be able to place the 8. So trying to put 1 or 2 here led to impossibility. So I can throw out that possibility. So this has to be a 13. Once again, my question is, where could I put a 9? I couldn't put the 9 here because then I'd have to use 9 and a 3, and the 3's already been used. And I can't put a 9 here or here, so the 9 has to go here. So these two numbers add up to 2 or 12. They can't add up to 2 because I don't have two 1s. So this would have to be a carry number, which means these two numbers add up to 8. So the question is now, where can I put the 8? And I can't put it here and get 8 plus 4 is 12 because I've already used the 4. And these two numbers are going to add up to 8, so I can't put the 8 here, so the 8 has to go here. And this has to be a 1. So now, to make these two numbers would have to add up to 12. So I can't go 9 and 3. I can't go 8 and 4. I can go 7 and 5. And then the remaining numbers I haven't used are 2 and 6. So that solves that puzzle. So here's another puzzle. So again, we write 9 or 18. And we find the digit sum, which is 5 and 4 is 9, which is equal to 0 mod 9. So I can ignore that and just write 4. Then I can connect these two because they're both even. Then I subtract and get 14, and half of that is 7. So this is 7. Okay, so suppose this was 9 and 8, and I carried 1. So if this is 4, I'd have to use a 1 and a 2. But if it wasn't, and this was a 4, then I'd have to use 1 and 2. Here, you won't be able to do the 5. So neither one of these could be 4. So they'd both have to be 14. And if you made 14, you wouldn't be able to make either one of those if the 7, 8, and 9 have already been used. So the conclusion is this can't be 9 and 8. So where would we put the 9 and the 8? Well, we won't be able to put the 9 or the 8 here. And we can't put both the 9 and the 8 in the same column. So we'd have to put either the 9 here and the 8 here, or vice versa. Well, suppose I put the 9 here. Now this is going to be 7, so I'd be carrying a 0. So if I put the 9 and a 5 here, then I'd carry 1. This would have to be 8 and 5. And I can't use the 5 twice. So it can't be 9, 5, and 8, 5. So if it can't be 9 and 8, it'd have to be 8 and 9. So then we know this would have to be 6. Carry the 1, and this would have to be 4 plus 1 is 14. So this would be 13 plus 1 is 14, carry the 1. And now these two add up to 4, so this can only be 1 and 3. And the only thing left is 2 and 5.